Morning, guys. Welcome to Quadratic Equation Functions Day 2. Our today is to create a table of values to graph a quadratic function. In the past, we've sort of sketched the quadratic function using the axis of symmetry and the vertex, and our a value to determine if it's opening upward or downward or if it's wide or skinnier. Well, today we're going to do a set of values, x and y table, to help us graph it. So this is in your notes on page, I'm sorry, I don't have it in front of me. It's on page 5. So if you turn to page 5 in your notes, and we're going to work through a few of these. So let's begin by finding the axis of symmetry. Let's begin by listing A, B, and C. Okay, so in this equation, A is 1, B is 0, and C is 0. From this, we can find our axis of symmetry. Remember, the formula for axis of symmetry is negative B over 2A. So that's going to be negative 0 over 2, which is simply 0. Recall, to find our vertex, we take that x value and put it back into the equation. So then we get y is equal to 0 squared. So we get the y-coordinate of the vertex is 0, which makes the vertex 0, 0. Remember, it's x, y, the axis of symmetry, and then the y-coordinate of the vertex. For all quadratic equations, the domain will be negative infinity to infinity for all quadratic equations. Now, to find that range, it may be helpful to graph this function. But notice the vertex, the y-coordinate of the vertex is 0, and because A is a positive 1, we know it opens upward. And the smallest value, so the vertex is going to be a minimum. So the smallest value, the smallest y value is going to be 0. Now, we haven't done the y-intercept before, but to find the y-intercept, we make x equals 0, which in this case also happens to be the x-intercept. I'm sorry, the axis of symmetry. So we're going to start with the axis of symmetry in the middle. And then we're going to take two values below it and two values above it. And we're going to place these values into the equation. So the first one would be negative 2 quantity squared, which gives us 4. Then it would be negative 1 squared, which is 1. Now, if you're doing this on your calculator and you're getting something different, it may be where you're putting your parentheses. So it should be parenthesis, negative 1, close parenthesis, squared. And again, putting in 1 squared, we get 1, and 2 squared, we get 4. So then we graph this set of order pairs. That's 0, 0, and then negative 1, 1, and 1, 1. And that is 2 and negative 2 are both 4. If you've done this correctly, then your answers should be symmetrical. Notice how our answers are symmetrical. 4, 1, 0, 0, 1, 4. Okay? Now, let's do the next one. Again, we need to find A, B, and C. So A is 1, B is 2, and C is 5. To find the axis of symmetry, we do negative b over 2a. So this is going to be negative 2 divided by 2 times 1, which gives us negative 1. Again, to find the vertex, we put negative 1 into our expression. Notice the way I put negative 1 in parentheses and then squared it. If you do it differently, you will get a different answer. So it has to be parenthesis, negative 1, close parenthesis, squared, plus 2 times negative 1, plus 5, and that gave us 4. So our vertex is the axis of symmetry, negative 1 and 4. The domain for all quadratics is negative infinity to infinity. Once again, we'll see that this will open upward, which makes it have a minimum value of 4. So our range is going to be y is greater than or equal to 4. To find the y-intercept, we make x equal to 0. So I have 0 squared plus 2 times 0 plus 5, and that gives me 5. So the y-intercept is just another way we can check to make sure we've done it correctly. Okay, so now we're going to start in the middle with -1 because that's our axis of symmetry, and we already have that's 4, we're going to take 2 above and 2 below. And then we put these numbers into the y value. So that becomes negative 3 squared plus 2 times negative 3 plus 5, which gives us 8. Negative 2 squared plus 2 times negative 2 plus 5 gives us 5. Now, once again, if we've done this correctly, we should see symmetry. Okay? And then we graph it. And of course, you would draw that line in. And we see that it makes a parabola. And it's symmetrical about x equals negative 1. The axis of symmetry. Alrighty, let's do the next one. Now, the only thing that's different about this one is that A is negative 1. Which means we know because A is negative 1 that it's going to open downward. So to find the axis of symmetry, it's negative 8. It's negative 8 over 2 times negative 1. Be careful with your signs there. Negative 8 makes it positive 4, but then we have 2 times negative 1, which makes it negative 4. So then to find our vertex, we put that x value back into y. Then our range, now this one is opening downward. So that means that negative 1 is a maximum value because it's opening downward, and our vertex will be a maximum. So this means that y would be less than or equal to negative 1. Again, the y-intercept, we would put x in for 0, and we see that our y-intercept is negative 17. So just as a reference, that y-intercept is going to be that last that constant in the equation, in the expression. So negative 17 is our y-intercept. Again, we start with our axis of symmetry, which was negative 4. We take 2 numbers below it, and 2 numbers above it. And we evaluate y equals negative 5, or y equals negative 6. Then we evaluate y equals negative 5. Remember, we're just taking these x values and putting them back into that original equation, just like we did with the vertex. And again, it should be symmetrical about the axis of symmetry. And then we graph those points. And voila, we're done. Okay, same thing for this one. We need to identify A, B, and C. So A is negative 2, B is 4, C is 1. The axis of symmetry would be negative 4 over 2 times negative 4, which is positive 1. To find our vertex, we put our the x value, the axis of symmetry, back into the y value. The domain will always be negative infinity to infinity. Now, once again, this graph is opening downward, which makes our vertex a maximum value. So the maximum this will be is 3. So then our range is going to be y is less than or equal to 3. Then the y-intercept, we make all the x values 0, and it's just going to be the number on the outside there, 1. Again, we put the vertex in the middle. We go 2 below it and 2 above it. And then we, my pi needs to be turned down, but I'll turn it down in a second. Then we put in values of negative 1 into the expression. And then we graph. Notice that it is going downward, and notice that we have a maximum. Okay, so let's try the next one. We need to find A, B, and C. Our axis of symmetry is going to be negative 6, negative 6 over 2 times 1. To find our vertex, we put 3 back into where the y is. The range, this is opening upward, so our vertex is going to be a minimum point. So this would be y is greater than or equal to 4. And remember to find the y-intercept. It's just that constant on the end. So the y-intercept is going to be 13. We start with the axis of symmetry. We go 2 below, 2 above. We put 1 in for x. Then we put in 2 for x. And it should be symmetrical if we've done it correctly. And then we graph it. Okay, so we've done the first y equals x squared minus 6x. We've done the first 5. And so if I were you, I would pause the video and do the next one. I think so you try 6. Remember on 6 that b is actually going to be 0. C is -4, but b is 0 in number 6. So I'd like for you to try 6 through 10. Make sure you find the y-intercepts as well. Okay? Pause the video and then the answers will be, I'll give you the answers in a minute. After you finish doing it on your own, pause it and then watch to see the answers. Here are the answers. And your homework tonight is page 9 in your packet, and you also need to complete the Day 2 exit ticket, which is on the Weebly site. So page 9 in your packet, and then complete Day 2 exit ticket. And you guys have a great day. Be on your best behavior while I'm out.